introduction, chromatography is a method used to separate and analyze mixes. It works by moving a mixture through two phases. One that stays will stationary phase and one that's mobile phase. Different components in the mixes move at different speeds, allowing them to be split. This simple and effective technique is used in many fields like chemistry, biology, and environment study to identify and study substances. In this presentation, we will look at how chromatography works and used and why it's important. Okay, next, I will explain the basic principle of the chromatography, which is a technique used to separate components and the mixes. Chromatography involves two main phases, the stationary phase and the mobile phase. These two phases determine how the components in the mixers are separated. How the component works is the stationary phase is fixed part of the system, with the mobile phase is the ones that move. Component with a stronger attraction to the stationary phase move slower. On the other hand, component with a weaker attraction to the stationary phase move faster as they carried along by the mobile.
For the next slide, types of basic chromatography. Here is a simplified explanation of the slide is thin layer chromatography or TLC. Uses a thin layer of material like silica on glass or plastic and a liquid mobile phase move the sample, separating its part. For the gas chromatography or GC, the mobile phase is a gas and the sample is carried through a column and separate substance based on their boiling points or how they interact with the column. For the third, liquid chromatography or LC, the mobile phase is a liquid that carries the sample through a phase column. Commonly used in drug testing, protein analysis, and environmental studies. Let me know if you like to add more details. For methodology, first, preparation. Select the appropriate type of chromatography, HPLC, GC, and TLC. Choose stationary and mobile phase based on the properties of the sample. Prepare the sample by dissolving it in a suitable solvent. Second, sample application. Introduce the sample into the chromatography system. Injection for HPLC or spotting for TLC. Ensure the sample is applied in precise and measurable amount. For third, separation. Allow the mobile phase to pass through the stationary phase. Components in the mixture interact differently with the stationary and mobile phases, causing separation. Fourth, post-processing. Clean the system to avoid contamination. Document findings and observation for reporting. Fifth, analysis. Interpret results based on separation patterns, retention factors RF or retention times. Compare with standards or reference material for identification. 6. Detection. Use appropriate detectors, UV fluorescence, mass spectrometry to identify or quantify the separated components. Record data in the form of chromatograms or retention times. Okay, that's all from me. Thank you.
Example of result. Red traveled a little but stay mostly together. Blue spread widely, showing it might be made of lighter pigments. Green broke into its components, revealing yellows and blues. And lastly, yellow stayed vibrant but travel a moderate distance.
Our recommendation for effective chromatography focus on achieving precise and reliable result while maintaining safety and sustainability. First is optimize conditions. To start, it is essential to select appropriate stationary and mobile paste based on the analyzed polarity. Controlling the mobile paste flow rate is also critical for precise separation. Second is choose the right technique. Using the correct chromatography technique is key. Paper chromatography works well for simple mixture such as pigments. TLC is suitable for purity testing and qualitative analysis. Next is column chromatography is recommended for large scale separation. For the third point is enhanced RF analysis. Accurately measuring solvent fronts and spots ensure more reliable identification and using standard help maintain consistency. Fourth is visualization and detection. For non-color compounds, visualization can be improving using the UV light nidring or iodine vapor. Fifth is safety and sustainability. Finally, prioritize non-toxic solvent whenever possible and adhere to laboratory safety protocol. By implementing this step, chromatography process can be significantly enhanced. To conclude, here are the references we use to this presentation. This resource provides us with detailed insight into the principle, application, and technique of chromatography. For example, we refer to the library text for an understanding of basic principle and news medical for real-world application of gas chromatography. Additionally, lab training and science directs offer valuable insight into specific techniques like thin layer chromatography and supercritical fluid chromatography. These references ensure that our presentation was accurate, informative, and comprehensive. That's all.
In conclusion, chromatography is versatile technology used in various sectors, including laboratories, forensic science, and environmental research. It helps identify complex substances and promotes innovation in fields like medicine, food safety, and environmental protection. Its simplicity and effectiveness make it cornerstone of scientific discovery for years to come.